Today we're going to talk about a quadratic equation and put it to a real life problem so that we can look at each part of the equation and interpret the pieces and make sense of it. So we're given this scenario. A baseball is thrown upward into the air. So stop and think about what path the baseball is going to take when it goes up into the air. When it goes up, it's going to find a maximum height that's going to peak out right here, and then it's going to come back down. That's the path that it should take. We would call this the maximum or the vertex of the parabola. Okay, then they tell us that the baseball's height in feet can be determined by this function, f of h equals. Now, f of h, they're telling you the y value stands for height in feet. F of h means y, and they're telling you that's the height in feet. So I know on my y-axis, this represents the height in feet of the ball. The rest of the equation, this part, says that t is the time in seconds after the ball leaves the player's hands. Now t is taking the place of your x, so this one's telling you that your x values stand for time in seconds. So if you could just interpret that part before you even start and know anytime that I ask you something about how high up in the air the ball is, I'm asking you to find a y value. If I ask you something about how long it took, how many seconds it was there, I'm asking you to find an x value. So this maximum, I could ask you, what's the highest that the ball went? I'm asking you, since it's height, for the y value of this point. If I ask you, how long did it take the ball to reach its highest point? How long is time? I'm asking you, how many seconds did it take? What is the x value of this point? I could ask you something like, when the ball is at 3 feet, how many seconds did it take to get there? And you would be finding the x value associated with the mark at 3 feet high. I could ask you at 5 seconds, how high was the ball? And you would find at 5 seconds the y value that goes with it. So it helps a lot to understand your equation. And before we start answering the questions, let's go ahead and put the equation into our calculator. So again, this is y equals, and you can type in the negative 5x squared plus 20x plus 15. Now, when you look at the graph, you want to be able to clearly see every part of this graph. So when I look at my graph, this is what I'm seeing. I'm going to adjust the window because I really need to see where this is going to peak out, where the maximum is. So if you press your window button, this shows you that you're right now showing from negative 10 to 10 on the x-axis, and on the y-axis, negative 10 to 10. Now, I really want to see up here higher. So instead of stopping at 10, I think I would like to just look and see if 20 is a high enough place to stop. Because again, I want to see the top of this parabola. So you can see 20 is not high enough. And I'm just guessing and checking until I can get my window where I see it clearly. I've got a good picture of the path of the baseball. So I changed it to 30, and I'm getting closer. I could pretty much tell from here, but I want to see every part of it. So I'm going to go ahead and put this up to 40. And there I can see the whole path of the baseball. Now, since I really don't care about this blank part right here, I'm going to go ahead and take out this part and take out this part so I can just center in on that parabola. So probably if I looked at 1, 2, 3, if I started at negative 3 and went to 1, 2, 3, 4, 5, 6, 7, 6 or 7, I'm going to change my x values to that. I'm going to start them at negative 3, and I'm going to end them at 6. And you can see what happens is that just squeezes in on this picture. So now I have a very clear, well-defined path of the baseball. So you know what's happening. The player throws the ball. It goes up, up, up until it reaches its maximum height, and then it starts coming back down, down, down. And assuming nobody catches it while it's up in the air, it's going to hit the ground right here. So now look at question number 1. What is the height when the ball hits the ground? In other words, what does h of t, because they ask for height, equal when the ball hits the ground? Well, sometimes I think you guys try to make these problems a lot harder than they are. When the ball hits the ground, how high up in the air is it? If it's on the ground, it's not up in the air, and the height is 0 feet. It's almost like a trick question. Look at number 2. Number 2 feels like it's asking the same question. At what times, what values of t, or x in your calculator, does the ball hit the ground? So they're not asking me how high up off of the ground it is. They're asking me at what time. So what they want to know is how long did it take. They want to know the x value of this point right here. And although this one doesn't make a whole lot of sense, and we'll talk about it in a second, it's also technically on the ground right there. So when y is 0, that's when these x values are happening. I can see on my calculator it's going to be at 1, 2, 3, 4. It's going to be between 4 and 5 seconds. And if you look at your table, at 4 seconds, the ball is 15 feet up in the air. At 5 seconds, it's negative 10 feet in the air, which doesn't make sense. But this tells me that somewhere between 4 and 5 seconds, that's where the ball landed on the ground, because the height switched from a positive to a negative. So at what times does this ball hit the ground? I'm going to say it's between 4 and 5 seconds. Now if you look at the other side, this is 0, this is negative 1. It's also at a little over negative half of a second. So if I look at my table between 0 and negative 1, at 0 it's 15 feet in the air. At negative 1 it's negative 10 feet in the air, which again we're going to address that in just one second, but somewhere between negative 1 and 0 seconds, this equation is also equal to 0. Number 3 addresses the weird thing we were talking about here. Keeping in mind what t represents, what values of t make sense in this problem? Negative time doesn't make sense. So the values that make sense is that between 4 and 5 seconds this ball was up in the air until it landed on the ground. So only the positive values for time are the ones that make sense.